So, hi everyone, welcome back to Data Science in a Pocket. And Microsoft has released yet another TTS version of VibeVoice, their frontier TTS model, that is VibeVoice Realtime 0.5 billion. And this time it's a real time model with just 500 million parameters. Yes, you heard it right. How to use the model, I think in the team has even released the version. This particular GitHub repo and Google Colab notebook they have released VibeVoice Real Time Collab. So I think it's very easy to run. It gives you a UI as well. Torch Coda is available. You need to install a few things. I'll be sharing the link. Don't worry about it. You need to provide your Hugging Face read token, which is free to generate, and then launch ViveVoice real-time demo. You need to follow this code and you would be able to run the command. So, and this is the UI that the code generates. You just need to run it. Let me type in something. What is in your head? Tell me now. So if I start it,
What is in your head? Tell me now.
it's quite interesting. You can change a few things. You can change the speaker, the streaming input text, and as you saw, it was almost real time. It didn't change anything. So now let's jump on to the different details of VibeVoice real-time TTS model. VibeVoice real-time 0.5 billion. It has a latency of 300 milliseconds, real-time streaming, 10 minutes continuous speech, and open source MIT license. What are the core capabilities? Real-time streaming TTS, long form generation, 8K token context window, 10 minutes of continuous speech it can generate in real time. Deployment friendly, obviously, yes. 0.5 billion parameters just for single GPU, you can use it. Single speaker consistency is there, and English only model for now, the smaller one. Streaming architecture, I think first of all the text input goes in, which arrives in chunks rather than full text. Sentences, then LLM encoding happens, and the encoding is done incrementally, and then acoustic decoding, and then speech output happens for you. Tokenization strategy, as you can see, 3200 is the downsampling ratio from 24k hertz audio input to 7.5 hertz acoustic tokens, and the decoder parameters are 340 million. Acoustic token stream, what are the design advantages? Minimizes signal bandwidth, enables back-to-back processing with low latency, removes semantic tokens, and reduces memory footprint. What is the model stack? I think a language model is there, Quen 2.5 0.5 billion, then acoustic tokenizer, and then diffusion decoder is there in the particular model stack. What is the training flow? And the tokenizer is pre-trained, sigma way acoustic tokenizer, and then the TTS training happens, LLM plus diffusion head. I'm not jumping much in the details. You can just pause here and read the slide to know more. What is the ViveVoice model lineup? I think they have three versions now. ViveVoice Real Time 0.5 billion, ViveVoice Standard 1.3 billion, and ViveVoice Pro 2.7 billion. The latency, as you can see, increases slightly, but as the latency increases, ViveVoice Pro provides you with the best quality outputs. Benchmarks, I think the model is quite good. We all know it last time also. If you look, ViveVoice is one of the best for speaker similarity, and even for WER, that is the word error rate, is quite low for this model. Deployment characteristics, I think precision is BF16. Latency, as mentioned, only 300 milliseconds. Parameter footprint is 500 million parameters, and inferencing style is streaming. Safety guards are also there. I think audible disclaimer embedded in all generated audios is present. There is a watermark also, and prevents voice cloning workflows as well. What are the prohibited uses? Voice impersonation without consent, disinformation, real-time voice conversion, and background audio or music generation. What are the known limitations of this real-time model? It just supports English for now. Single speaker, apart like compared to its previous versions, which are multi-speaker. This is single speaker. No code support. It can't read code. It can't read maths, special symbols. No overlapping dialogues. Can't model multiple speakers. Speech only. No music. No ambient sounds. So the version that I was showing you was the Vibe voice in general. And what are the potential biases inherited from Quen 2.5 base LLMs? So there will be certain biases coming from Quen itself. What makes it unique? I think interleaved processing, that's for sure. Parallel text and audio pipeline, extreme tokenization, remove semantic layers, and tightly coupled design is there. What's the bottom line? I think focused implementation on low latency speed synthesis, that is very important, because now everyone wants to have a voice agent in their local system, and I think Vibe Voice Realtime 0.5b provides that to you. Edge deployment is there because of the small size. With this, it's a wrap. I hope you try out the new model Vibe Voice 0.5b real time, and let me know in the comment section how you feel about it. Thank you so much.